Hey guys, so today we are going to do 4.4 log equations and functions. So the first thing we're going to look at is finding the domain. Well, think of the graph itself, right? So if we drew a sketch right now of a log, it would look something like that, right? And as you can see, it would never cross the y-axis because there is an asymptote there. So let's think about what we need. Well, what that means is that it can never be, it has to be greater than 0, right? So that's the idea. So what we do is we take what's in these parentheses, okay? Remember the 2 is the base, so that's why I'm not using the word base. So we're going to take that part in the parentheses and we are going to set that greater than 0, because remember, it can't be negative and it can't be 0. Those don't exist. So x squared plus 1 is greater than 0. So x squared is greater than -1. Well, x squared will always be a positive number, right? So this will always happen. With that, since it's always happening, the domain will of course be all real numbers, which we can put in interval form as negative infinity to infinity. Okay, just remember that happened because anything squared is always going to be greater than a negative number. Now, of course, if I took the square root of both sides, we would come up with a statement that can't happen. So make sure you make that judgment along the way. All right, and B, now remember what I said earlier, it's only in the parentheses. This, remember, according to our transformations, makes it go up and down. It doesn't make it move left or right, okay? So that's why we only have to deal with what's in the parentheses. So I get 1/2 x plus 1 is greater than 0. So 1/2 x is greater than -1, and x has to be greater than, well, how do you get rid of a 1/2 there? We can multiply it by 2. So we get -2. Again, let's put this into interval notation just in case our answers are not accepted as inequality. So x is greater than -2 means -2 to infinity. Let's keep in mind that it is not equal to, so we have to have a parenthesis there. All right, one more that is a little bit tricky here. So if we look at this and we say x over x plus 1 is greater than 0, what does this look like? This should look like our algebraic solving rationals functions, remember? So the one thing we have to do is what makes the numerator 0? Well, what makes the numerator 0? So that means x is 0. And we have to think of a vertical asymptotes, right? So that's x equals -1. So when we do our sine ray, we have to include both these values. Now, the great thing is I don't have to worry about being it filled in or not because all of this is not equal to whether it's a vertical asymptote or not, so I don't have to worry about that. But let's keep in mind that everything's positive, everything's 1, so negative, 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 positive, positive, negative, negative, positive, so we get positive, negative, positive, and it has to be greater than 0, so we have our 2 intervals, which is negative infinity to -1 and 0 to infinity, and there is our domain. Now we're going to get into graphing. So these are a few things that will help us graph. First, we want to talk about finding the domain. Then we're going to do the x and y intercepts if that exists. Remember, x-intercepts are when y equals 0, and y-intercepts are when x equals 0. So that will help us solve for everything. We're also going to think about our transformations of how it shifts up, down, left, right, reflections. And if we need any additional points that might help us, keeping in mind the vertical asymptote and so on and so forth, okay? So this is gonna help us with graphing. So let's do this now. Let's change our page here. Okay. Now, it says sketch the graph of f of x log base 3, 1/2 x plus 1. Okay, so what we're going to do is find the domain first. And we just learned how to do that on the other side. If you remember, this is the same domain as, I think it was part B, so I'm not going to solve for that, okay? If you guys need to remember how to solve for that, we did it right over here, okay? So we know that the domain is -2 to infinity, okay? And then we also want to keep in mind, and I want to do this straight off the bat, that the vertical asymptote will always be that numeral that is either the greatest or less than, okay? So in other words, our vertical asymptote is going to be where x, because x is vertical, sorry, my nose is in the camera, -2, okay? So vertical asymptote at -2. Now we're going to look at our x-intercepts. Remember that our x-intercepts are when y equals 0. So I have log base 3 of 1/2 x plus 1 plus 1. And we're going to set that equal to 0. And we're going to start solving. We can't get rid of the log base 3 yet until we move that 1 to the other side. So I have log base 3 1/2 x plus 1 equals -1. Okay. How do we get rid of the log base 3? Well, we have a base 3. Those would cancel. But let's remember, whatever we do to one side, we must do to the other. All right, so we're left with, on the left side, 1/2 x plus 1 equals 1/3. Because remember that negative exponents means fractions, not negative numbers, okay? And you can check that on your regular calculator if need so. I actually have no calculators around me right now because I want to make sure that I'm practicing with that one. All right, so we have to subtract 1 from both sides. We get negative, or 1/2 x equals -2/3. Again, you can do this on your calculator if you want. Also keep in mind, do not use decimals because a third keeps repeating over and over. And if you start rounding that, it changes your whole answer. Okay, x equals, and if we multiply that by both sides by 2, we get x equals -4/3. So what does that mean? Because many of you, if it wasn't a multiple choice question, would write this wrong. We remember that next intercept is a coordinate pair, so it would be -4/3, comma 0. Okay, I used up a lot of space, so I'm probably going to go around, guys. Y-intercept is when x equals 0. So we have log base 3 of 1/2 times 0 plus 1 plus 1. Okay, so when we have our coordinate pair, we get 0, comma, well, let's see, log base 3 of 1. Okay, so let's keep that in mind. Actually, I want to write this out for you so you guys can see it. So if we have log base 3 of 1 plus 1, well, let's look at this right here. 3 to the what is 1? 3 to the 0 is 1. So this evaluated would be 0. And 0 plus 1 is 1. Okay. Let's also keep in mind our transformations, right? Of course, x is multiplied by 2. Remember, we have to do the opposite. The plus one on the inside means, the plus one on the inside means it goes right, no, left, one. And the plus one on the outside says it moves up, one. All right, let me see if my colored pencils here, or my pens, come out correctly. So we have a vertical asymptote at -2. We have a -1/3. And we have a 0, 1. So that's great. Now, again, if they wanted more points, we could just plug in 1 and 2 and so on into our calculator if we have to. But we already know that it's going to come down like this. Okay. And what did we do? We moved left, we moved up, because remember it would have been right here. 4. Okay. Awesome. We just graphed it without a calculator, guys. Okay, let's do this. This one's going to be a little bit more trickier because of the absolute value sign. Okay, so when we look at the domain, we need to think that the absolute value of -1 is greater than 0. Okay, so in other words, right now, the only thing that doesn't work, because absolute value is always going to be greater than 0, right? But 0 is not greater than 0. So what x value makes it 0? X cannot be 1. Did you guys see that? Okay, absolute values will always be greater than 0, but it is not equal to 0. So we got to figure out what point does not work. So that means our domain is -∞ to 1 and 1 to infinity. Okay. Let's see, our vertical asymptote. Of course, that means, well, what's the only value that can't work here? 1. So x equals 1 is our vertical asymptote. X-intercepts. Okay, let's set this equal to 0. We get log x minus absolute value of x minus 1 equals 0. All right, let's think about this, guys. First of all, log, it doesn't have a base, but does it? What is it? 10. So we get rid of log by doing base 10. And whenever we do one side, we do the other. Okay, so those cancel. We get the absolute value of x minus 1 equals, well, 10 to the 0 is 1. Make sure you guys keep that in mind, because a lot of you messed up and put 0 there. Okay, now, what makes this true? Instead of solving and trying to figure out, hey, what's going on with, well, I guess we could do it in the solving ways. Think of this. What values do we want to set this x minus 1 equal to? Well, really, how to get 1 here is if 1 or -1 is in that absolute value. Let me repeat that. The values that can come out of that absolute value, come out would be 1. Well, what values inside would make it 1? 1 and -1. So I'm going to put both of those values right there. So that inside can be 1 or -1. Now we solve. That means if I add 1, I get 2, and I get x equals 0. Okay, if I add 1 to the +1, I get 2. If I add 1 to the -1, I get 0. So let's remember our coordinate pair. So that's 2, 0, and 0, 0. Ooh, there's 2 x-intercepts. What's going on here? Okay. Y-intercept. All right, let's set this equal to 0. So log absolute value of 0 minus 1. Okay, well, the absolute value of -1 is 1, so log of 1. Wait a second, that's asking ourselves 10 to the what equals 1. So that means y equals 0, which makes sense because you can't have an x-intercept being 0, 0 if the y-intercept is not 0, 0. Okay, let's start graphing before we need to figure out what's going on here. So, x equals 1 is a vertical asymptote, so that's nice. We have an x-intercept at 2, 0, and we have an x-intercept at 0, 0. All right, what is happening here? Well, one of the things that you guys really haven't learned when it comes to transformations yet, but you will in AP Calc or Calculus, is that absolute value on the inside actually makes things reflect across the y-axis. Okay, so what's happening here? Because we're not reflecting across the x-axis. And what I mean by reflecting is it doesn't go away and flip on the other side. What I mean is actually mirrored on both sides. So what happens here is, remember, I can't cross the absolute value, but what happens is it comes up and it reflects the same way here. And if you wanted to get very particular, of course, all you have to do is plug in numbers and find out exactly where they go. But absolute value on the inside makes whatever is on the right side flip over to the left. Awesome. All right, let's see what else this has in store for us right now. Now we're going to do some solving. Okay, remember, once you have potential solutions, you need to check to verify if they work or not, okay? So be careful on that. So let's talk about this. ln. Well, how do you get rid of an ln, guys? That would be e. And the great thing is it's on both sides, correct? Awesome. So when we look at this, we get x squared minus 3x minus 1 equals 2 minus x. Now, I see that there is an x squared in there and x to the first, which means it's quadratic, and you should move everything to one side and see if you can factor it or not. If it's not factorable, we do the quadratic formula. Do you guys see how I'm coming up with a plan before I even start writing things down? This will help things go smoother. So I'm going to stick with x squared as positive. So moving everything to the left side here. I'm going to add 1x. And I'm going to subtract 2. Now, when I factor this, I end up with x minus 3 times x plus 1, which gives me x equals 3 and x equals 1. Now, remember we talked about domain. It has to be greater than 0. No negatives, no zeros. So what happens is we have to double check. If I plug in 1, I get 1 minus, oh, this should be -1, sorry. 1 plus 3, which is 2. 2 minus 1 is 1. So we're good on this side. Let's check both sides. -1 here. That's 2 minus -1. So yes, -1 works. Now let's try 3. That's 9 minus 9, which is 0. 0 minus 1 is -1. So this does not work because we have a negative. The other way we could have done this faster is 3 minus 1, 2 minus 3 is -1. You can't have negatives in that spot. Okay, so the only answer is x minus 1. One of the biggest mistakes you will make is you will forget to check. All right, so one of the things we need to look at when solving is if we have to rearrange anything, whether it be move everything to one side, whether it's using our rules of multiplication and division, because we can't get rid of a log until you only have one log showing. Okay, here is a little bit different because we didn't have anything extra. Even though we have 2 ln's here, there's nothing extra with adding on or not. So we don't have to worry about that. But in this case, we do. You see we have 3 terms and only 2 of them have log in here. So the first thing we're going to do is move the logs all on one side. So get log base 3. Don't forget to write that base in because we need that later, right? 4 minus 5x. And then we have minus log 3. I feel like my head is right in the camera. Sorry, guys. X minus 4 equals 1. Okay, next thing. Where do we go from here? You cannot get rid of a log until there is only one log there, and I see 2. We have a log minus the log. How can we change that? Well, minus means division. So to condense out, we get log base 3. So we have 4 minus 5x all over x minus 4 equals 1. Now, as you can see, we only have a log base 3, one of them. So we can get rid of it now. We get rid of it by doing a base 3. Whatever we do to one side, we do to the other. These cancel. We get 4 minus 5x all over x minus 4 equals 3. So we have the first 3. Let me scoot that up so you guys can see the work. All right, let's solve. We can do this. We don't like the fraction. Let's get rid of the fraction. So 4 minus 5x equals 3 times, now don't forget parentheses, x minus 4, because the whole thing's multiplied. Let's go back to 6th grade when we did distributed property. 4 minus 5x equals 3x minus 12. Okay, move x's to one side, everything else to the other. I'm going to do this in one movement so we go faster. And we get negative 8x equals negative 16. So x equals 2. Now remember, most of us have a tendency like, yay, we have a solution, let's move on. But what did we learn last question? We have to check our answers. So if I plug in 2 here, so if I go 4 minus 5, so let me write this as check so you guys see, times 2, or 2 minus 4. If you see, they are both negative numbers, which can't happen. So no. What does that mean? If we just cancel 2 out, what does that mean? It means no solution. You have to check. Let's do one more, and then we're going to do some application with it, okay? So, solve the equation. Well, I see 3 terms again. I see that we have 2 logs, but luckily for us this time, they're all on one side. I need to get it into one log. Okay, so I have a log plus a log. Well, addition means multiplication. So I have a log, and now I'm going to write this out so you guys can see it. I have x plus 2 times 5 minus x equals 1. Okay. How do you get rid of a log? Well, that means the base is 10. Whatever I do to one side, I do to the other. So I'm left with x plus 2 times 5 minus x, and 10 to the first is 10, which means we're going to have to do this multiplication out. I'm going to do it quickly. So I end up getting negative x squared plus 3x plus 10 equals 10. The great thing about this, guys, is the 10s are going to cancel, right? So I get negative x squared plus 3x equals 0. They have an x in common, so I can take that out. Negative x times x plus 3, or minus 3 if I'm taking out a negative x, sorry. Taking out a negative x. Minus 3 equals 0, which means x equals 0 and x equals 3. Okay, don't forget that x out front means 0. All right, what do we have to do next? We have to check. So let's see. We have 0 plus 2, that works. 5 minus 0, that works. Now let's check our 3. 3 plus 2, that works. And 5 minus 3, that works. They both work, so that is our answer. All right, one last question and we're done with 4.4. Okay, let P of T be the population of the state of Utah in millions 2 years after 1970. In 1917, Utah has a population of about 1.06 million, assuming a constant rate growth of 2%. The population of Utah satisfies the equation in P of T. Find the population of Utah as a function of T. The population of Utah in 2008 is about 3.16 million. Compare the actual population with your calculation. Okay, so what we are doing, guys, is first of all, we are going to get P of T by itself. Okay, now this is going to be the tricky one. This is a trick question. You need to know this. Okay, so let me write this down. We have ln P of T equals ln 1.06 plus 0.02 T. All right, so here is what I'm worried about. I'm worried about the fact that, yes, before I was talking about, since we have two ln's, why don't we move it to the one side? But as of right now, we have two variables, okay? And we are trying to solve this as first we want the function of t. So we want P of T by itself. So I'm going to do this different way, okay? Pay attention to my movements. Okay, to get rid of ln on this side, I must e it. So whatever I do to one side, I must do to the other, okay? Now, I want you guys to keep in mind that this is an exponent. In the past, what are the situations that we would add exponents? Sorry. And think of backwards. When we were adding exponents, we were actually multiplying two of the same bases, right? Like this. If I said x to the third times x to the fifth, you would tell me it is x to the 3 plus 5. Okay, see that? But we are going backwards. We have an addition, so we're going to split it. This allows me to keep P of T by itself. Okay, so we get e to the ln of 1.06 times e to the 0.02 t. See, now I separated it into multiplication. We also know then that these two will switch or cancel. So I'm left with P of T equals 1.06 times e to the 0.02 t. All right, now we have our calculation here. We have our function. Now let's talk about t. 1970 to 2018 is how many years? It is 48 years. So what we're going to do now is put 48 in for our t into our calculator, okay? Just make sure that when you plug this in, I'm going to show you how to plug it in. 1.06 times e. Now some calculators will do a caret, some will just have a space, but make sure that whatever you put into the exponent there, have parentheses around the 0.02 times 48. So we remember that the 48 does go into the exponent also. And when we come out with this, we get 2.768. Now, what does that represent? That represents millions of people, right? So if we think about this, this is 2.7, but they said it's about 3.16. So what happened here? It's an underestimate. So when it compares, you would say it's an underestimate. In other words, P of T, the model, is an underestimate. Awesome, you guys. That's done with 4.4, and I'll be recording the next one really soon.